Alright class, what we're going to be looking at today is ellipses with a center not at the origin. You can kind of see a real life representation of this with, say for instance, the orbits of the planets around the sun. They're all elliptical. So, let's get started. Now of course one of the things you're going to have is make sure that you have the notes on the equations of the standard forms of ellipse, because that's going to help you a lot here. So we're going to graph this ellipse. Now if you look at this, we've got x minus 3 over 36 squared plus y plus 1 over 9 squared equals 1. Now this is a horizontal. How do we know that it's horizontal? Well, the reason we know it's horizontal is because 36 is the largest number. It's under the x, so it's going across the x-axis. So if it's horizontal, we know that 36 is our a squared. So if a squared is equal to 36, that means a is going to be equal to plus or minus 6. B squared then has to be 9, so b is going to be equal to plus or minus 3. Now to find c squared, remember we use c squared equals a squared minus b squared. So c squared is equal to 36 minus 9, which equals 27, or c is going to be equal to plus or minus 3 square root of 3 if you simplify square root of 27. Now, pulling out all the information we need. Once again, go back to your formulas or your standard equation sheet. The center we found is got here 3 and negative 1. Your vertex, or your vertices, are h plus or minus a and k. So h is 3, a is plus and minus 6, and that's our k. So 3 plus 6 gives me 9, 3 minus 6 gives me negative 3. Those are my two vertices. CV, which is our co-vertex, h and k plus or minus b. H is 3, k is negative 1, and b is plus or minus 3. Plug those in, you get 3, 2, and you get 3 and negative 4. And of course to find the foci, we use h plus or minus c and k. So once again, all we're doing is plugging in what we got, 3 plus or minus 3 square root of 3 and negative 1. That gives us all the information we need to graph this. We find our center first at 3 and negative 1. Then we go 9, negative 1. We go negative 3, negative 1. And then up to 3, 2. Down to 3, negative 4. Draw your ellipse, and there you go. Now, let's look at another one that's given in a different kind of form. Kind of guys remember where we talked about completing the square. Alright, so this one here, first thing we got to do is make sure we combine the things that are like. X's with x's, y's with y's, and move your constant term over. So if we do that, we've got 4x squared minus 24x plus our blank, plus y squared plus 4y plus our blank, equals negative 24 and two blanks over here. Now, remember, we've got to factor this 4 out. So this is where I get the x squared minus 6x here. Now when I do that, we're going to take half of that. Half of 6 is 3. 3 squared gives you 9. 9 times by 4 puts 36 over here in my blank. Over here I didn't have anything I had to pull out, so I'm just going to halve my 4, which gives me 2. 2 squared is 4. 4 goes here, and 4 goes here. So now we have perfect squares, so we get 4, which is this 4, x minus 3 squared plus y plus 2 squared equals 16. It's negative 24 plus 36 plus 4 gives me my 16. Guys, remember we talked about today is we got to make sure this has to be equal to 1, so we're dividing everything by 16. That's going to give us x minus 3 squared over 4 plus y plus 2 squared over 16 equals 1. And then we go and we pull out all the information. A squared is 16, so a is plus or minus 4. B squared is 4, so b is equal to plus and minus 2. C squared is equal to 16 minus 4, which equals 12. And c is equal to plus or minus the square root of 12, or plus or minus 2 square root of 3. Hopefully you're all still with me. If not, stop me, rewind. Alright, now we know this is vertical because our largest number is over here under the y. So it has to be a vertical. So we pull our center. We got our centers at 3, negative 2. And then we go through and use the standard forms and the equations to get our vertices, our co-vertices, and our foci. Now what we're going to look at is writing the equation of the ellipse from given information. Here we're given that the vertices is -4, negative, and +4, and 6 and 4. And then our foci is -2, 4, and 4, 4. Now, from this information, we know that the major axis is 2a, which is the distance between the two vertices. Your major axis is distance between the two vertices. So 2a is equal to the square root of -4 minus 6 squared plus 4 minus 4 squared. You work all that, you're going to get a is equal to 5. Now you should remember your distance formula. Distance formula is x sub 1 minus x sub 2 squared plus y sub 2 minus, or y sub 1 minus y sub 2 squared, and we take the square root of the whole thing. That's where this came from. So 2c represents the distance between the foci. So same thing, 2c is going to be equal to the square root of our foci here. So we got -2 minus 4 squared plus 4 minus 4 squared. C is going to be equal to 3. So we've got A and C. We know that we can find B using our formula, so we square C, we square A, we find B squared. So we got 9 is equal to 25 minus B squared, or B squared is equal to 16. Now that we have that, the other thing we need is our center. So our center is the halfway in between the two vertices. So if we've got our two vertices up here, halfway in between means we're going to take -4 plus 2 divided by 2 and 4 plus 4 divided by 2. That's going to give us 1 and 4 as our center. Now that we have our center, our B squared, and we know A squared is 25 here, all we do is plug this into our formula. We also know that because the y coordinates are the same, this graph is horizontal. So we know exactly where A squared and B squared are going to go. And last but not least, we're going to write the equation of the ellipse with vertices at -2, -4, -2, 8, and it has a length of a minor arc equal to 10. And I got to grab a marker real quick. All right, here we go. So, once again, we have the length of the minor arc is equal to 10. Well, if you remember your minor arc, that's 2b is equal to 10. So that tells me that b is equal to 5. And we also just a minute ago talked about the vertices. Well, 2a is to be equal to the distance between these two. So if 2a is equal to the distance, we've got -2 minus a -2 squared plus -4 minus 8 squared, and we take the square root of that whole thing. This will give us 2a is equal to, this is 0 here, this is 12 here, 12 squared is 144. We take the square root of 144, we get 12. So a is going to be equal to 6. So we know that b is equal to 5, so b squared has to be equal to 25. We know that a is equal to 6, so a squared has to be equal to 36. Now the biggest thing, of course, we need to know is this horizontal or is this vertical? So we go back and look here, where are our vertices? Our vertices are obviously on the x-axis, because we got -2, -4, and -2, 8. The -2's don't change. Or is this horizontal? I hate it when I make a mistake in the middle. That's all right, because I can cut and paste. Where's my notes? So, -2, -4, -2, -8 means if we're at -2, we're going 1, 2, and up 8 would be somewhere up here. -2, -4 would be somewhere down here. So obviously this is vertical. And if it's vertical, that means that we're going to put the larger number underneath the y squared. So for our center, which we still need to find, our center we know is at -2 because those are the two things that didn't change. And then it's going to be halfway in between the -4 and the +8. So to find out halfway in between there, we've got -4 plus 8 divided by 2 gives us a halfway point, which would be 4 over 2, or that's going to be equal to 2. So, our center is at -2 and 2. So this would give us a center x plus 2, y minus 2, and then 36 here, 25 here, and that's going to be equal to 1. Now what I want you guys to do tonight is work these problems here, work all 4 of these before you come in. That way when we, I'll know that you watched this video. If you don't have these problems ready for me, then I'm going to take points off. You got it?